Abdul Rahman. I'm a lecturer at a public university in Kenya. I deliver lectures in computing and informatics. In our last lesson, we discussed user-defined function type 4. Basically, we had seen that the user-defined function type 4, it is the one which takes up an argument or a parameter list and also has got a return value. So, in the two conditions, it cannot take up void. Today, we are going to move on to another topic, and that particular topic, we are going to answer the question, what is a recursive function? And on that particular journey, we are going to define a recursive function. We are going to find out the syntax of recursive function, and then basically we are going to implement what is a recursive function. So what actually is a recursive function? So a recursive function basically will say it is a function that calls itself. So it is a function that will call up itself. And where does it call itself? It calls itself in the function definition. In our previous lesson, we've seen that the concept of a function, we have to have what you call a function declaration, a function definition, and a function call. So it's going to call itself inside the function definition. So if we can remind up ourselves, if this is a syntax of a function, and here we are talking about type 1 function, which the return data type is void and the argument is void, then our recursive function is going to call itself here in the body, because all this, it is a function definition. So here we are going to have our recursive function. So this leads us into the syntax of a recursive function. So basically, the syntax of a recursive function, it's very simple. It is, let's take for example, if this is our main method, so we have got our int main, and we know that before the int main, here we are calling, here we are declaring our function, and here it is where we are calling up our function. So here we can call up a function. Let's take for example, that particular function is what we call recursive. So basically this is how we are going to call up our function. However, let's see how, because we are saying a recursive function is calling itself in the definition. So let's have a definition of our function here, and maybe we will call it void recursive. And in the body here, let's take for example, there's some statement, and then we are calling it again here recursive, and then we have some statement here, and then we close up. So here we have a function called recursive, which is actually, according to the principles of a function, we are supposed to call it within a main, but we are calling within the definition of a function. So this is what we call up a recursive function, because we are calling it within the definition of a function. So this is what we call up a recursive function. But let's see logically how this particular recursive function works. So if you have got a memory here, the stack memory. Now, what happened here? First, we are calling up this because according to how the C programs work, after the main, the next statement is the one which is actually executed. So our statement here, we are calling this particular function. So here, basically we are calling this particular function. So this is number one. So if you are calling this particular function here in the memory stack, we have this recursive. And then after calling this particular function, it will execute this particular line, this line 1, and then come to this particular line 2. So when it comes to this particular line 2, what will happen again? It will call this particular recursive function again, because this one now points back here, and then it will go back again to do line 1 and then to do line 2. So this one will be calling the recursive function again and again until this memory stack becomes up full. When it becomes up full, the computer gives up an error, and that particular error, it will say insufficient memory. So actually this one creates a loop, and this loop will go forever and ever until the memory is full. Therefore, with this particular recursive function, we should have a condition to stop it. So whenever we want to program and call a recursive action, we should have a condition which is supposed to stop this particular program. Therefore, for demonstration purposes in Dev C++, if we have similar problem, then we are going to use the keyboard Control-C to stop up the program. So the program, otherwise if you don't use Control-C to stop up the program will go on and on until the memory is full, and then it gives you insufficient memory. So basically, that takes us into the next step, and the next step, we are supposed now to demonstrate recursive action in Dev C++. So let's demonstrate. So by demonstrating it, we are taking up our type 1 function. So you're going to say void recursive So here basically what we have done, we have declared our function, and here we are going to call up our function. So how do we call up type 1? Just by its name. So recursive and then by its name. So actually that is how we call up our function, and then basically after the main method we are going to define our function. So here we'll have void recursive, which is type 1, does not return any data type. It does not take up any values. So opening and closing brackets, and then here basically you're going to say maybe a very simple printf, and in that particular printf we are going to write up the word demonstrating recursive function, and each statement must be terminated. So we terminate that particular statement, and then now here we are calling again the recursive function. We are calling here recursive, and then we are putting up another printf, maybe a printf, and here we are saying this statement will not execute. And why this statement will not execute is a very simple logic. Is because this particular recursive, once here, this is the first execution, and then this will be the when this execution will call up our recursive function, and then it will pass on by the print statement, and then here we'll call again a recursive action. So this one now will create up a loop. This one will create up a loop. So this particular loop, in order to stop it, basically we're going to use control plus C. So control C. So let's try now to run this particular project and see what happens. So when we run this particular one, you can see actually here only the words demonstrating recursive have been repeated so many times. So this one will go on until the memory is full. Now to stop it, we just do control C, and there it has actually stopped. So this is the end of this particular part. In our next lesson, we are going to continue and see what are actually the conditions which are going to be implemented in order not to get up an infinite loop. So thank you for listening. However, don't forget to subscribe into our next videos, and for now, bye.